Now that we've got a decent idea of what's going on as far as indefinite and definite integrals are concerned, let's talk about what's referred to as the net change theorem. The net change theorem relies on our ability to recognize the total amount of change in something. For example, when we say something like delta y, that's generally referred to as the change in y, and typically the way that we would calculate something like that is by subtracting two different y values. When we talk about a change in x, or delta x, we generally arrive at this by subtracting two x quantities. Now you'll notice though that in the fundamental theorem of calculus part 2, that also involved subtracting two quantities. So the net change theorem actually states the following. The integral of a rate of change is referred to as the net change. The notation that we can use for something like this would be that the integral of the first derivative of something would be the total amount of change in f. This is called the net change in f. Now the net change in f is referring to an overall change rather than an actual moment-by-moment change, as it were. As an example, let's say that we are dealing with a velocity function. Velocity, as we know, is the first derivative of a position function. We usually refer to a position function by the use of s. So the integral from a to b of v of t dt would be like saying the integral from a to b of s prime of t dt, which would be s of b minus s of a. This would be referred to as the net change in position. It simply says this is where the object started and this is where it ended. It has nothing to do with the path that got you from point to point. Now, with that in mind, this is also referred to as a displacement. Now, displacement is very closely related to distance in the following regard. If we were to take the definite integral of the absolute value of a velocity function, then this would be the overall change in distance. Now in our next video we'll go over an example of the difference between those two things.